Hi Algebra 2, this is Unit 6, Lesson 7, and today we're going to talk about quadratic inequalities. Alright, so just to make sure we understand about inequalities in general, I have this inequality in exercise 1, x squared minus 3x minus 10 is greater than 4, and I want to test it out to see when x is 4, is that a solution or not. So basically I'm just substituting in 4. 4 squared minus 3 times 4 minus 10, I want to see if that's greater than 0. So 4 squared is 16, negative 3 times 4 is 12. So I got 16 minus 10 is 4. 4 minus 10 is negative 6. Is negative 6 greater than 0? No, it's not. Okay, so that is not a solution. Look at B, I want to substitute in 2. So 2 times 2 squared plus 13 times 2 minus 7, and I want to see if it's greater than or equal to 0. So I have to do the exponent first. 2 squared is 4. 4 times 2 is 8. 13 times 2 is 26. 8 plus 26 is 34. Minus 7 is 27. Is 27 greater than or equal to 0? Yes, so that's a solution. All right, now let's look at the next one, exercise 2. I have solve x squared minus x minus 6 equals 0. So I'm not even talking about an inequality yet, but I will in a second. So I want to solve that. So let's factor it. So I got x times x is x squared. Now the 6's can be tricky because the numbers multiply to 6 and they add up to negative 1. Alright, so the only way it's going to be a negative 1 if my numbers are 3 and 2. 3 times 2 is 6. And the only way to get a negative 1 if it's negative 3 and positive 2. And then I take each factor and set it equal to 0. So all that does is change the sign. So my solutions are x equals 3 and x equals negative 2. Now, if the equal sign was changed to a less than or equal to sign, would we have more, fewer, or the same number of solutions? Back up here, I just have 2 solutions. But if that equal sign was changed to a less than or equal to, I would have definitely more solutions. In fact, I would have an infinite number of solutions. There would be more solutions though. So with an inequality, why they're trickier is because there are more solutions. And the problem is, what are the more solutions? So here's a graph, it's already done for you, of x squared minus x squared minus x minus 6. All right, you can see we want to identify the roots. So the roots are just the solutions. The roots are the x-intercepts. So my x-intercepts are right here at negative 2 and positive 3, which I already knew that answer from part A up above. So my roots are x equals negative 2 and x equals 3. Basically, the roots are just the solutions, the zeros, the x-intercepts. All right, D, I want to highlight the section of the graph that represents when x squared minus x minus 6 is less than or equal to 0. So basically, it's right here, this section of the graph. It's below, here's my x. This right here is my x-axis, right? Any solution below that is where x is less than or equal to 0. All right, and then they just want me to graph the solution, so I'm going to do that on a number line right here. So remember, my actual solutions were negative 2 and positive 3, so I want to make sure I include negative 2. And I also want to make sure that I include positive 3. And I just squeeze that in. And there is an equal sign, so I'm going to have closed circles. And my solution is everything in between those numbers. Okay? Most of the time when I have these inequalities, you're going to have an infinite number of solutions. So I can't just list the solutions, all right? I'm going to, you'll see that we'll have, we'll use our inequalities symbols in my solutions. All right, so if I'm looking at exercise 3, and I want you guys to do this in your calculator, So if I go to the calculator app, for some reason it turns off the video. So you go to your calculator, all right, and I want you to put in, I'm going to do it at the same time. So if for y1, I'm going to put in x squared plus 2x minus 3, all right? And I want you to fill in the table right there. So if you go to your calculator, y1, and you're going to have x squared plus 2x minus 3, and then I'll copy down my table. Oops. I'll do it again. X squared plus 2x minus 3. All right, I'm going to go to second table. And they want me to copy down the values from -5. So I'm going to have to scroll up. So -5 is 12. -4 is 5. -3 is 0. -2 is -3, -1 is -4, 0 is -3, 1 is 0, 2 is 5, and 3 is 12. All right, so that's my table. Actually, part A I skipped, so let's do part A. They want me to solve this, so I'm just going to factor it. All right, so I got x. So the only factors are 3 and 1. I just have to figure out the signs. I want it to be a +2, so it's going to be a +3 and a -1. And then I set each of those factors equal to 0. And I solve. And we're going to see in a second that matches up with my table. So I get x equals -3 and x equals 1. Those are my two solutions. And look, those are my two solutions right here. All right. Explain why the zeros you found in part A are not part of the solution set. So they are not going to be the solution because I don't have, look at this inequality, it just says less than 0. So I want all the solutions that are less than 0, and those solutions are going to be right here. See how my solutions, I'm specifically looking at my solutions right here. Okay, this is where it's less than 0. And part C, which we already said, why are the zeros not part of the solution set? Because I am looking for everything that is less than 0, not equal to 0. I'm looking for solutions that are less than 0. There was no equal sign on that inequality. All right, and then if I have to write the solution set of the inequality and represent it on a number line, all right, so basically my solutions are, let me include -3, -2, -1, 0, 1, 2. All right, so my solutions, 1, 0, okay, but I'm not including 1, so I'm going to have an open circle. And -3, but it's everything that's in between there. But again, I do not have a closed circle because I'm not including -3 and I'm not including 1. How can I write this? I can write x such that x is less than 1 and greater than -3. Okay, and that's how I can write my solution. So how do I do this? To find the solution set of a quadratic inequality, you're going to find the zeros. So basically you're going to do exactly what we did before. Make sure it's in standard form, everything on one side equal to 0. Find the zeros. All right, so you're going to factor it. Create a number line using the zeros. Watch for open or closed circles. Test the points between the zeros and outside the zeros. So I'm going to test in between and I'm going to test on the outside, and then you're going to write the solution set. All right, so I'll show you how you do that, but in reality you can just be putting this into your graphing calculator and looking at the table instead of testing. Okay, so you can use your graphing calculator and you can see where, and look at the table, and you can see where those solutions are less than 0 or greater than 0. So that's another way to do that, and probably an easier way to do that. Anyway, so how do I do this? This is in standard form, so I'm going to factor it. This is the difference of two perfect squares, so I get x minus 2, x plus 2. Okay, I set each factor equal to 0. So basically, I have, if you're looking at a number line, all right, I have my solutions are at -2 and 2. I want to test out, and this is going to be an open circle, okay, -2 and 2. I want to test out a solution that's between them, okay, so let's test out when x equals 0. All right, so I'm going to put in 0 for x. So 0 squared minus 4 is less than 0. Well, 0 squared is 0, -4 is, I'm sorry, and it's greater than 0. That is not a solution. So I tested out something that was in between them, didn't work. Now let's test out something that is on either side of them. So let's test out 3. 3 squared minus 4 is greater than 0. 9 minus 4 is greater than 0. 5 is greater than 0. Yep, that worked. Okay, so basically my solution is going to be this way. And I'm going to test out -3. And I'll show you an easier way to do this. But I did want to show you how you can test out your solutions. So I'm going to test out -3. So basically -3 squared minus 4, that's 9 minus 4. Is that greater than 0? Absolutely, because again, I'm going to get 5. So this also worked. So this is my solution right here. All right, so I have to find that here. This says x greater than 2. Nope. This says x is less than 2 and greater than -2. That's the one in between the numbers. Nope, that didn't work either. This says x is greater than 2 or x is less than -2. This is the one. I got 2 solutions right here. All right, but I can easily just do my graphing calculator and look at the table to see. Also, if it's greater than, okay, so if it's a greater than, your solutions are outside. If it's less than, your solutions are between. And the only difference is if it's a -x squared, the rules reverse. Okay, so whenever you get your factors and you get your zeros, all right, if it's greater than, your solutions are between those zeros, and if it's less than, your solutions are outside. So on this one right here, so I have my greater than right here. See how that's greater than? So if it's greater than, then your solutions are outside the zeros. If it's less than, your solutions are in between the zeros. And that was like the one up above. See right here? So this was a less than. My solutions wound up being in between the 2 points. See, in between right here. If it's greater than, right here, my solutions were outside the zeros. All right, so let's just practice this. So let's solve the quadratic inequalities. Write your answer in step builder notation. All right, so I'm going to factor this. Everything's in standard form. Nice, nice. I'm going to factor it. So I need factors that multiply to 36 and combine together to give me a -5. So that's going to be 9 times 4 is 36. The only way it'll give me a -5 if it's -9 and +4. So my solutions are x equals 9 and x equals -4. Now let's look at this, and you can verify this by doing it in your graphing calculator. This is a less than. When it's a less than, my solutions are between the numbers. Okay, so if I have like -4 and +9, my solutions are between them. You can test out solutions. You can see this in your graphing calculator, but if it's a less than, your solutions are between them. So let's write this in set builder notation, x such that, and I'm including them because it's less than or equal to. So I'm including the -4 and I'm including the 9. Done. All right, so B, I got a factor on B. So I'm going to set, it's in standard notation. So I'm just going to 5x times x is 5x squared. This one's a little bit tricky because of factors of 12. Factors of 12 are going to be 2 and 6. Now the 6 needs to go here because 5 times 6 is 30 and 2 times x is 2. So 30 and 2 can give me that 28. all right? And that's going to be -2 and +6. So my solutions are x equals 2/5 and x equals -6. Now this is a greater than, all right? So that means if it's a greater than, your solutions are outside. So 2/5 is the same thing as 0.4. And you don't have to graph it. I don't think it said I had to graph them. And then -6 is over here. So I'm not including it, but greater than my solutions are outside. So basically it's x such that x is less than -6 or x is greater than 2/5. And that's my solution right there. All right. So we have some multiple choice. The number line graph is the solution to which of the following inequalities? Look at it. It's between the numbers. So between the numbers, that means that I am looking for a less than situation. I'm looking for a less than situation. So I'm going to get rid of choice 1 and I'm going to get rid of choice 3 because they both had greater than. Next thing to look at, look, I'm including those. Those were closed circles, so that means I need the equal sign. Choice 2 doesn't have the equal sign, so therefore it is choice 4. All right? And just to verify, you can put that into your graphing calculator to see, or you can factor it to see what those factors are, whichever is easier. Number 6. All right, number 6, I have a greater than sign. All right, so that means that my solutions, actually I take that all back because look, I was going to say my solutions are outside. Whenever it's negative, your rules are reversed. So I'm looking for something that is between. Usually with greater than, the solutions are outside those zeros, but if it's a negative, the solutions are going to be between them. All right, so I'm going to get rid of this and this right there. I'm going to get my pen back. You can put this into your calculator, but my solution is going to be a decimal, so you do have to change the table to 0.5. All right, and if you do that in your graphing calculator, or if you factor it, you're going to see that your solutions are 0.5, 0, and 3, 0. So that's why it is choice 1. Okay, and we'll practice that some more tomorrow.